Hi, we are the Plasma Table Senior Design Team. Our names are Rees, Nathaniel Eastman, and Teresa Hoving. Our advisors are Scott Meneguzzo and John Irwin, and our team was sponsored by GM. Our senior design team was tasked with repairing and improving a plasma cutting table for the MMET machine shop. At the beginning of the project, the plasma table was unable to cut material accurately because the torch wobbled during use. Our team investigated the cause of this issue and found the guide rail to be severely worn and corroded. To better understand the severity of this problem, we programmed the table to cut out 2-inch squares at multiple locations. The resulting cut was not accurate to the original program, especially in the middle of the table, as seen in these pictures. Our team's goal was to restore the plasma table's ability to make accurate cuts and to improve the durability of the rail system. During our research, we found that the most high-end plasma tables have 2 rails to support the torch, whereas ours only had 1. To maximize the durability of the rail system, our team decided to incorporate a 2-rail design into our solution. Our final design involved replacing the worn rail and retrofitting an additional rail for increased stability. We first replaced the worn rail to return the table to functioning condition. Shown in this picture is the profile of the worn rail next to the new rail we installed. The new rail has distinct lines and sharp corners in its cross-section, while the old rail has a much smoother profile from years of wear and corrosion. With the plasma table functional again, our team began working on a project for Blue Key Honor Society. Blue Key wanted fire cages built for Winter Carnival. We used the plasma table to cut our designs into sheet metal for the fire cages. The fire cages were completed for Winter Carnival 2024 and will be available for use in future years. Next, we started the manufacturing and installation process for the second rail. To avoid interference with pre-existing parts, we positioned the second rail over the ball screw. We decided to manufacture the riser brackets in-house to cut down on costs and to control the overall height of the rail once installed. The brackets designs were chosen based on FEA performance and manufacturability. After the brackets were welded, they were machined to final height and painted. The riser brackets were designed to be bolted to both the secondary rail and the plasma table to allow for adjustment. During installation, a dial indicator was used to verify that the second rail was parallel to the primary rail. Another aspect of our solution included corrosion protection. To that end, we drained the fluid from the plasma bed and replaced it with freshly treated water. We also added a splash guard to mitigate rail exposure. While the table bed was drained, loose paint was scraped off and a new coat of paint was applied. At the end of our project, the plasma table now looks and functions like a useful piece of equipment. Thank you for your time.